Quadratic functions, Math 112 or Pre-Cal. Well, if you wanted to graph one, and we've been graphing them a while, but just as a good review, a quadratic is just when your highest degree is squared. So if I had this and I wanted to graph it, we know with the x, we do what makes it 0, or right 2, up 3. Nothing out front, so it's average. There's also not a negative out front, so it's up. Now, when you're doing this, there's a couple of things as far as that you can find. The lowest point, in this case, is a minimum. It's also the vertex, is what it's called, but the vertex is a minimum, and it's at the coordinate 2, 3. Well, a couple of neat things you can say about that. As far as domain, all reals, because it goes on forever, so it can be anything it wants to be. However, the range, look how the smallest it goes is 3, which is also the y coordinate. So the range would be 3 to infinity. Something called the axis of symmetry that cuts it in half. I'll just abbreviate it. Notice how is a vertical line here at the x-coordinate of the vertex. So that would be x equals 2. Not just 2, but x equals 2. So if those always have to do with the vertex, if I know, like let's say, if I know it's positive, as far as lead coefficient's positive, and my vertex, I don't know, we'll say -1/8. Well, and as long as I know it's parabola, domain's all reals, my range would be, it's positive, so that means I'm going from something to infinity. And remember, range always goes with y, so it's actually 8 to infinity. And then the -1, axis of symmetry, x equals -1. Now, yes, you could graph that, left 1 up 8. So that's what it would look like. As far as the equation, it would look something like this. Left 1 up 8. As long as it wasn't skinny or wide. So that's something you can do. You can also find the x and the y intercepts. The x-intercept is plugging in 0 in for y. The y-intercept is 0 for x. So let's say I had something like y equals x squared minus 4x minus 12. And if I wanted to know what are the x and y intercepts, well, if it's like this instead of like this, the good thing is you don't have to foil it and make it like this. To find the x-intercept, 0 in for y, and on purpose I gave you one that's factorable, x minus 6, x plus 2, because multiply to get 12, subtract, give you 4. So 6 and -2 are the x-coordinates. And remember, we plugged in 0 in for y, so the x-intercepts are going to be 6, 0, -2, 0. If you're looking for y-intercept, 0 in for x, so 0, 0, -12. So there's your y-intercept. You can also find the graph the way we did, but if you're just looking for and trying to find the x and the y-intercept, that's what you would do. And I notice how both of these, they don't have an x-intercept because they're up there. Now, if you wanted to find the exact y-intercept, if you plug in 0 in for x, 1 squared 1, plus 8, 9. So actually the y-intercept would be 0, 9. Like I said, if this was below and you were looking for it, you could FOIL it out and then add the 8, and then it would be like this, so you could see how to factor it, or worst case, quadratic formula, which I know I can just feel you cringing even though I can't see you. And as far as one other thing that you're looking for is, let's say it's like this, but you want to graph it, because it's got to be in standard form to graph it. All you have to do is complete the square. Remember, you get your x's together plus blank, bring down the minus 12, and remember, since you're working on the same side, if you add the blank, you got to take away the blank. And to find the blank, you always do the same thing. Divide by 2, then square. So -4 divided by 2, -2, squared, 4. Did it over here, did it over here. And remember, this factors to x minus 2, which is just x minus 2 squared, just like up there, minus 16. So if you wanted to graph this, right 2, down 16, up and average. Domain all reals, range greater than or equal to -16. So you can complete the square in order to find the whole graph to see where you go. Let me do one more, complete the square, and then I'll show you a formula that you can use if all you want is the vertex and you don't want to graph it. Let's say 3x squared plus, what do we want? 18 or 18x plus, I don't know, 12. Or let's even, 12, whatever. No, we don't want 12. Let's say 11. So if I want to complete the square, notice how I can't complete the square without the x, the coefficient gone. So I need to take it out. But remember, you only take it out of your x terms, not your constant. Whatever this is, you just bring it down, add in the blank, subtract the blank. Remember, to figure out what goes in the blank, you divide by 2 and square it. So 6 divided by 2, 3, squared, 9. Now the only thing is, notice how we didn't just add 9. We added 9 times 3, or 27. So -16. And then this, it does factor, but remember the shortcut is this divided by 2. Will work every time. So that's another one, completing the square. Now let's say, I lied, let's do one more. If I had -x squared plus, I don't know, 8x plus 13. Notice how this one has a negative out front. So you're going to take a negative out of your x terms, blank, plus 13 minus blank. Well, to figure out what goes in the blank, it's just normal. Divide by 2, 4, square it, 16. But notice how this, we actually added -16. So that means we need to add +16. So in other words, if there's a negative, you're always going to add the blank. This divided by 2, negative 4, plus 29. There you go. Now, last but not least, let's say I gave you something like x squared plus 5x plus 4, something that you wouldn't want to complete the square with. Let's say I give you this and I just want the vertex. All you have to do is to find the x coordinate of the vertex. It's negative b over 2a, which should look familiar, part of the quadratic formula. This is going to be tough. Yucky. Oh, well. Negative b over 2, and a is 1. So that's going to be negative 5 over 2, or negative 2.5. Now, if you want to find y, if that's your x, you just plug it in. So negative 5 over 2 squared plus 5 times 5 over 2, negative, almost forgot, plus 4. So 25 over 4 minus 25 over 2 plus 4. I could use my calculator, but might as well do common denominators. 50 over 4, if you just multiply by 2. So negative 25 over 4 plus 4. Still, I could use calculators, but I like to do it in my head if I can. So negative 6 1/4, if you make it a mixed number, plus 4. Negative 2 1/4. Yuck. But that is the vertex of this. It's positive, so that means a upgoing parabola. So it's a minimum. So you can find it without completing the square. Now, if this was a nice even number, it would have worked out better. Let's say if I had 3x squared minus 12x plus 7. Looks kind of bad, but so I have negative b, or positive 12, over 2a. So that would be 12 divided by 6, 2. So if my x coordinate's 2, to find my y, you just plug it in. 3 times, you can tell how this one's much better, 2 squared minus 12 times 2 plus 7. 4 times 3, 12, minus 24 plus 7. Negative 12 plus 7, negative 5. So that's the way you can find the vertex without even graphing it, by doing negative b over 2a. And then technically, if you ever see it, it looks like this, but that just means plug this in to your equation for x. And there you go. The quadratic word problems I will do next, but it won't be until later on in the first part of next week on Monday, which are quite interesting, and you can see some real life applications. Hope this was of help to you. Have a great day.